try to get there about 9:30 because their kitchen closes at 10. Gladly serve drinks, but they don't like to serve food after 10. So,
Is anybody planning to go to Unix next month?
excuse me?
Unix is supposed to be in Boston next month?
Yes, I put the announcement up earlier.
Oh, sorry.
Yeah, June 25th to the 30th in Boston. And it's the Unix Technical Conference. And there will be a big section on Freenix, on Linux and FreeBSD. I'm going to run down and get a soda.
Okay. All right. Well, first of all, I'd like to thank everyone for having me come here to speak. My name is Brad Snow. I'm a student at Boston Linux Institute. About to graduate. I've been doing research, two research projects for the last year involving wearable computing. One involved with wearable application design, the other having to do with StrongARM design. And what I'm going to just talk about today is wearable application design and practice for designing software for use on wearable computing systems. First of all, what exactly is a wearable computer? I actually have a prototype that I put together, but I didn't do it. The MIT back on wearable computing defines a wearable computer as portable while operational, meaning that while you're walking down the street, while you're involved in a conversation, you're jumping up and down, you're actually capable of using the system. It's always available, unlike some other types of computing devices. Whenever you need it, it's there. There's no need to take it out, no need to open it up, no need to turn it on. In fact, many wearable systems don't even have an off switch. Context aware. This is really broad. Basically, what context awareness is, the machine is capable of having awareness of the environment you are in through various types of sensors, things such as GPS, IR, location, tags, audio, video, all sorts of things of this nature. And different applications can use this information in different ways to help increase the user's situational awareness. Hands-free or almost hands-free. This would be an example of an almost hands-free user input device. This is a Twiddler 2 keyboard system. So just PS2 keyboard you can plug in. The original Twiddler was actually serial-based and required a driver. Other types of input devices include things possibly like joysticks. Speech recognition is very important in being researched for military and industrial applications where it's extremely really important to have your hands free. Those and other types of input as well. And also attention getting for the user. When the machine has something to tell you, it has to be able to indicate that to you. Steve Mann, who was one of the early researchers in wearable computing, also defined a few other points about a wearable computer, saying, first of all, it does not monopolize the user's attention. This is different than a desktop system. The whole idea of a computer is that it assists you in performing the tasks and doing the things that you're going to be doing anyways. The primary task is not computing. It's there to assist you. For instance, if you were going to the store and it could remind you about your list of items to get, or if you were at, say, a book sale, you could potentially have a database and information where you could look at the information on the book, or have a scanner and scan the ISBN number. They could bring up information about that book and tell you whether or not it's good to purchase or not. If you're trying to sell books or something of that nature. There's a lot of different possibilities, but computing is not the primary task. It doesn't interfere with the user's ability. The user should be able to do things that they would if they didn't have the computer on. One of the fundamental principles of a wearable computer is that it be unobtrusive and not get in the way. Because if it's actually getting in the way and making it more complicated for you to accomplish the task you're doing, you're It's not serving its intended purpose at all, and no one will use it. Observable by the user, that's self-explanatory. You need to be able to see the display. Show later. This is a micro-optical display. It's a 640 by 480 glasses mount display. Architect actually works very well, but it's always there. You open your eyes, it's there. Like a watch, you have to actually move it up to your head to look at. It's just there. Around 2,500, but I didn't buy that.
Same prices.
Well, it's more or less on the road from micro-optical for a period of my projects. They were very nice. Right. The device is a 10F2 environment that falls into the context awareness factor I was talking about before, where it can increase the user's situational awareness. And the device is communicative. That is, the device is capable of communicating to the user. It could also possibly be capable of communicating to other people around the user, for instance, through audio, in addition through networking and messaging, email, and those types of communication systems. Now, some people may be thinking, a PDA is wearable computing. It's a pretty common, question. Because when you keep it in your pocket, it's small, it's capable of performing computing tasks, but there are some fundamental differences between a wearable computing system and standard PDA. First of all, the PDA has to be taken out, has to be turned on, and you have to be holding it and looking at it. Most PDAs are also pen-based, so that will require you to be using both hands, which then makes it even more difficult to be doing other tasks as well. Also, they usually lack the sensors and other things required to enable context awareness. There are things available, like for visor, the springboard for GPS and other things, but actually having a full set of everything you need is difficult. And there are two basic models of application design. Well, not really design. It's more or less what the application is to accomplish. So there's kind of two major sections. There's one which is wearables that are designed for performing specific tasks. These are, for example, there was a wearable that was designed by Carnegie Mellon for technicians on Shell Oil, like specifically for inspecting and getting a history of the boat and knowing what areas were safe to go into and what weren't. There's also another thing that Carnegie Mellon did was a real-time speech language translation. We would use speech recognition on people talking in one language. We convert that to text and do text conversion for one language, and then we I know the right word. Speech. Yeah, speech synthesis for you to hear it. And I mean, that was being used for military applications. I don't know what exactly doing. No, basically, those are designed to assist for specialized tasks, and the user puts them on when they're doing the task, and take it off when the task is done. General purpose personal wearable computing is user-centered, centered around the user's activities and the user's life, what they're doing. It's there to help them. It's worn at all times, well, almost all the time. Probably not to the shower or swimming or things of that nature. You could. And also, it scales well to many applications. It's designed to be, more well, I can't say necessarily more robust in all ways, because there are some specific task wearables that are designed to blow up or cause sparks or things, well, because they were being used in hazardous environments. But as far as the capabilities and the applications, it's capable of performing a lot more, running a lot of different applications as opposed to being designed specifically for one application. You could have a task-based wearable which has 4 buttons, for instance, whereas a general purpose wearable would need something of this nature where you have the ability to do a full keyboard or things of that nature. So there are physical differences that could prevent that. those are the two basic models. Wearable interfaces. Traditionally, wearable computing researchers used Emacs. Emacs was everything, and sometimes it still is. Which for the particular purpose, was a good choice. Emacs is very flexible, it's very extendable, it already has tons of built-in capabilities, and if it doesn't, someone else probably has already written it. You can have psychoanalyzed pinhead and Dr. Program. But I mean, seriously, it has has built-in scheduling, has built-in access to shells, and it has a scripting language. So this was and also it was text only, because the early displays that people were doing, such as the private eye or monochrome, they were only had tech capability, but could be wrong. But I know that they definitely used Emacs in the text mode. Some of the cons are Emacs is pretty complex for normal people. That assumes you're all normal. But for instance, you probably wouldn't have your grandmother try to use Emacs.
Where do you think I learned it?
I'm sure there are instances where you would.
Well, this install
But in
Emacs
general,
speak.
I've tried using Emacs speak, but every time it does, it says you need a desktop card, and I haven't found an emulator or anything. And I don't have a desktop.
They're not cheap.
Anyways,
That's because Roland used to work there.
right, those are not very intuitive. What I mean by not very intuitive, for instance, there are some interfaces where you do one thing and you see something similar, and most likely if you're going to accomplish that task, you're going to do it in very much the same way. Where as in Emacs, everything is Control X, Control S, Control X, something else, and unless you actually go through and hit tab and look at all the different commands or read the manual, or you're just used to it, you're not going to very likely stumble upon the commands you want by just having an idea of what you're supposed to do. That's what I mean by intuitive. And also, in general, it doesn't have many graphical capabilities. You probably wouldn't want to use Emacs for watching a video, for instance. Though you probably could with Emacs. Now, what about the point-and-click interface? I have a pointer here. I can use it with the twiddler, but I really wouldn't want it. Simple tasks become complex physical challenges. You could be walking down the street. Now imagine this with the display on. The display is moving with your head. You are moving. Your hand's moving. The device you're trying to manipulate is moving. Plus, you're trying to use something. Let's say in this particular instance, a small little thumb track thing to point to something. This just doesn't really work very well. I've tried it.
What do you mean it's touch screen? So put less on.
They did try that out, but too many people were poking their eyes out. It didn't catch on very well. So, we gotta say, putting devices are hard to use, but there's more than just the fact that the difficulty positioning of it. It's the fact that it actually requires you to look at the screen. One of the, because again, going back to one of the primary principles of a wearable computer, it's not your primary task, it's there to assist you in doing other stuff. So if you're having a conversation, you don't want to have to refocus your eye on the actual display, which you do even though it's head mounted. There is a shift in focus because of the distance that it's placed from your eye. You don't want to have to do that. You want to know that when you hit a button that it's going to perform the task that it's supposed to perform. You have to be fiddling around positioning some strange, icon graphic thing. That doesn't work. Yeah. Also, most wearable computing systems, again, they have a small display. This display here is actually pretty large for a wearable computing display to be colored. 640 by 480. Most color wearable computing displays right now are 320 by 240. There is the Sony Blastron, which is 800 by 600. However, it's basically this giant goggle type sort of thing. It looks really cool, but it gets very hot. It also is difficult to actually see through. Most people, and this is what I did with the one I have, is to take out one of the eyepieces so that you can actually look through it. Otherwise, the transparency is very poor.
What's the time to use your head as a
Yeah, it does actually happen. You get hot and you can get sweaty and it's just, it causes headaches, things of that nature. I've had no problems with this display. But I haven't used it extremely long term either. That is another thing with head-mounted displays in general. Different people will react to them different ways, especially when it's only covered in, like afterwards, other people come up and look at it, or I will pass it around and you can come up and look at it, or put it on, whatever. What was I going to say?
In terms of the abnormality of the
Well, no, I was saying, right, actually, like, the use of a head-mount display is varied for different people. For instance, some people like it on the left eye, some people like it on the right eye. Right-handed, so my left eye is dominant, and I prefer it over my left eye. When I first actually was using the glass drawing, and I was taking out, choosing to figure out which eye piece to take out, I took out the other one, and it was just so weird. I mean, that's really the only way to describe it. It just feels weird, things look weird, and it's different for different people. So, I mean, that is an actual physical adjustment to being used on these things.
Did you find that you had problems with headaches or just the eye after a while? Do you see the work properly?
I would say that I didn't actually get a full-blown headache or anything like that issue, but I definitely felt this one. Now, challenges of wearable human-computer interaction. I was talking about this.
16 hours a day? We're only 16 hours a day.
I don't think I'm awake 6 hours.
Neither is John, but you know.
I haven't actually done it. I've worn it for maybe 3 or 4 hours at a time. I've just gone into classes and on displays. It's interesting to see how it
Now,
So you
how
get-
long does it take before other people stop noticing it?
I haven't had that happen yet. I mean, if you go to the board lab over in the media lab,
Go over that unless you don't have.
well,
Outsider.
Yeah.
so I already basically covered these points here. The other thing was the fact that it's an LCD or an LED display. The glass one I was talking about is an LCD display. It's similar to kind of like a projector. It has a light behind it. It has a little crystal diode matrix, and it shines light through it. This device here actually uses an open display, and it's a MEMS device without the acronym stands for it. I should remember some things from my mechanical engineering class I just had, but basically what it is it uses very small type devices which actually stuff like that, I'm not sure about. But there are 3, and it actually has 3 different LEDs, which one for red, green, and blue, and they get turned on in a certain sequence, and that's how it simulates different colors. And the effect of that when you move is that the color will start to shake, and it won't be steady. One of the ideas that have been proposed is putting an accelerometer on the displays in some way, so that when you're actually moving, that it will go to just a grayscale mode, in which case you can be able to see everything fine. And also consequently, since you're using 2 additional LEDs for the same color, it increases the brightness as well. So those are some of the hang-ups, of the displays. Things displayed on the LCD. Input devices are unfamiliar to people. If I handed this to one of you, you'd probably have to look at it to look at the patterns. It's just right there how to use it. It's not natural. Not that keyboards are originally natural, but most people who have computers are familiar with standard QWERTY keyboard. Most people are not familiar with QWERTY keyboards, and it does take time to adjust to. Limited capability. Joysticks, smaller keypads, you don't necessarily have as many keys or options available, and pointers are difficult to use. So these are, yes.
you have problems with like carpal tunnel or hand fatigue using this sort of?
I haven't yet. In theory, I would think that I would, because I type a lot, I play bass guitar, and I use this thing. But I think if you keep, yes, at the same time. So you can use this as a slider. I think the key though is just to keep your wrist straight and not actually curve it while you're moving your fingers. That's what I was always taught by my mom, and she was one of those old school typists. Well, she was taught this a long time ago. She typed on manual keyboards and typewriters, and I've never thought of carpal tunnel. Sometimes, you know, I think it could be an issue, but if you've got to make sure, I would say make sure your wrist is straight. You probably won't have a problem.
How long have you been using that?
This, I would say a few months. Certainly not, I have not transitioned to using this as my primary input device. I would use this for coding right now at this point. I have typed, some emails using it. I've done control of my application, which I'll be showing later, which I designed specifically for being able to be very easy to use with this type of device. But I don't think I've used it enough to say that. Would be possible. Yes.
Have you seen those ring mice, the little track balls that fit like a ring on your finger here?
I don't think I've seen it, but I think I know what you're talking about.
Because they're like $25 on computers or something like that. I thought, something like that would be really good. Like if you didn't need a full twiddle, or let's say you had some application where you could just choose from choices of options.
Sure. You could have an application which is designed, let's say, where you have possibly like a ring or order or some sort of, just a set of choices that you cycle through. There have been instances with an application designed where you use a small wheel, similar to what you'd find on some cellular phones, in order to cycle through options, and then you push it in order to select one. That would be found more in like a task-specific, wearable application, as opposed to for general purpose thing, but it certainly could be a useful input device.
Addressing the trackball, the main problem I see with those trackballs is that you're only using two fingers, and so you can left click and drag, but you can't right or middle click and drag. And recording between the two fingers is going to be nearly impossible because the trackball's in the way. The other thing is there's not much support for the ball, so it's hard to do. It's actually very hard to do fine motions with it because the entire device is moving as your hand moves as you try to move the trackball, and if it's stiff, then
You can always get your hand search wheel.
there you go.
It won't be better than like wrist mounted. Like let's say you had it like mounted like a watch band.
Yeah, that would help to keep it something.
Again, if you're actually in a position where you're going like this, you, for the most part, very much restricted the use of this hand and crossing across your body.
I could drive like this.
Yeah, but don't discount it because nobody does one task, and anytime we do one task a thousand times, that's when the problems come. So there is a voice recognition user as well, and so this is the problem of input is one of enduring concern.
Oh, absolutely.
And so one of the pluses for the Twiddler, although the one person there's a lot of other things there, but given that you said the straight is absolutely, but it's easier on the Twiddler user, as are some ergonomic keyboards, because you don't have the angle, the way the torque is, the angle of your hands.
Right.
It's weird, it's unnatural, it's flat,
Right,
and it's unlike it. The best one in some of the studies is the most expensive, I think, is actually this data pad or something, data hand, and it actually looks like two big mouse pads, for the fingers. There's no one thing that repeatedly being done will not hurt you, so therefore the constant good advice is to have multiple pieces. And so when you're talking about this hand one, which I actually am working on, it's an advantage because there are some times when you want to just scribble like you would on the back of a business card,
Sure.
or to show somebody directions, and it's very much like the graphics card can be extremely useful, but not have listening to the hand, but having it just so people have told me, I've asked only, but it's kind of 300 or 400, that I'd like to show them that disagree with this, maybe double the size of a credit card to be on
keyboard?
As a screen image. No, this is for
Oh,
scribing.
okay, I think I know what you're talking about.
Scribing, just for scribbling.
All right.
You have,
So you
well,
might,
it's a double, it's, yeah.
so you might go just put a Palm Pilot.
Well,
It's about that size.
you don't have, you're picking up a one, well, for the prototype, we're using Palm Pilot, but yeah.
Thank you.
Okay, more challenges of wearable HCI. Information representation. Since you're dealing with such a small screen, it becomes important to figure out what exactly you should be telling the user, what information they need, and what information they need now. When that's one of the areas where context awareness will come into play, is determining which information is actually useful at this point in the user's current context. Font size and readability versus the quantity of information. This is a pretty common problem. You want the fonts to be readable, yet you don't want them to be so large that you can only fit 4 letters on the screen. So this is an issue you have to address to get the right balance. Use of color, contrast, intensity, and color combinations. As anyone who's done web page design should know. Certain, yes.
Interesting about the fonts, you like that with the capital 6, so that they will have to go with trans,
That certainly could be a good compromise and possibly useful for certain applications.
And other ones are, like with the cell phone, they're starting to integrate, you're going to this small screen, some problems, but the marquee, the rolling marquee, so.
Right.
Especially if you have the control of the speed of the marquee, if it's going too slow for your attention, or it's going too fast, either way, it's really a bad match with that physical, real time, like you're saying,
Right.
scrolling, whatever the thing needs to make it scroll, that can be controlled also for the speed of this thing. You can have something large enough to actually even be seen by 2 people when you do want to share the information. So the font size is not just a real tiny 14 point up to the whole screen. So that middle ground is pretty useful.
Yes. You were saying kind of like a stock ticker.
Yeah.
Yeah. It really depends upon the application, what would be the correct solution. Different colors don't look good on each other or are very hard to read. You want to try to avoid these. When you're dealing with a head-mounted display that's on for a long period of time, you want to stay away from colors that have high intensity or things that will cause eye strain. Yes?
Probably want the colors somewhat customized for too, because people have different reactions.
Customizable is always good.
Yeah, and not just for contrast, but also for dyslexia. There's a very high percentage of great, miracle brains, and there's a higher percentage of dyslexia in my speed, so having anxiety things, and that was one of the figures that were going through and becoming graduate students here and what their strategies were. And one is very literally the color itself of the background and the font. Literally, if it's not the one that they need, it makes the letters vibrate in a very minor way that you wouldn't realize it, but they have measured it, and that's part of the reason problem with reading, period.
That actually is similar to one of the effects you'll find, which I had to deal with, which is when you, like, let's say you have a red and blue. Since red is at one end of the spectrum and blue is at the other, if you have high intensity, high saturation versions of each of them next to each other, you can get a 3D planing effect, where one is actually higher up or higher off the screen than the other. And I actually had to deal with that, and what I did was I chose desaturated versions and on an LCD display. It doesn't have any. Feedback. Use of visual audio feedback and to inform the user of when a task was accomplished. Anytime the user actually performs an action, there should be some sort of feedback saying, okay, I know what you told me to do, I'm going to do something about it. Just in general, that's a good HCI principle. The question is about what type of feedback and when to use what type. For instance, you would not want to have an audio announcement in the middle of your class. Again, a context where a machine would know whether or not it should be using audio or some sort of visual thing, depending upon where you are and what you're doing. The response... Absolutely. absolutely. I have to try. Yes.
Have there been any considerations for like earbud, the way you have the little tiny visual cameras that can just also on your discreetly quite nice?
I would think so. I haven't come across it yet, but I wouldn't be surprised. Oh, wait, you mean just like the headphone earbuds?
Yeah.
Oh, yeah, those are like built into the classroom. Yeah. Definitely. That's so response time as well is important in any application. And handling error messages and most importantly in trying to design the applications to ways to prevent any errors to begin with. Obviously, if you're driving down the street or something, you don't want to have loud exposure or something. You want to have an error message which explains what's going on and lets the user rectify the situation as quickly as possible, especially when they're dealing with a time-critical task where they really don't have the time to deal with making mistakes. Some general HCI guidelines are, this is from the Ben Schneider book. He's HCI. These are just some principles which in general for any application, but some of them are very, are important for wearable applications more so. Striving for consistency within the interface, which will, again, increase the intuitiveness of the interface. Enable frequent users to use shortcuts. Again, once you get used to using the computer, it's personal, and you don't want it to feel as a hindrance. You want it to assist you, so being able to have, shortcuts, things of that nature for new users is a good thing. Offering informative feedback, again, having error messages that make sense, as opposed to just a number. Things that, inform not what the problem is, but how to correct the problem. Things of that nature. Design dialogues that yield a closure. What that basically means is that when you're performing a task, the process you go through needs the user to know when it's done. There's like a beginning, a middle, and the end. The reason for that is that when a person is thinking about the task they're accomplishing, they're coming up with ideas of different ways of doing it, different things they'll try if what they're about to do doesn't work. And once they actually get closure, they'll stop thinking about that task and move on to the next thing that they have to do. And again, that's facilitated with this type of closure through feedback in the interface. Error prevention and simple error handling, things, for instance, preventing the user from just deleting all their files, not letting them do that, or at least informing them when they're about to do that by having a warning message. This is something that's pretty standard in a lot of applications. Easy reversal of actions, the basic undo feature. It's really good so the user knows they can explore the interface without destroying anything. Some people are afraid to try different things out, they'll only do what they're used to or have been told. But if they know that what they're going to do can be undone just by a single keystroke, if they know it can be done with something just a simple keystroke, they'll be more likely to go through and use the interface and feel comfortable with it and not be afraid of it. Support internal locus of control. This basically is just saying that the user should feel as if they're empowered, not as if the application is empowered. If they're trying to get a certain piece of information, for instance, if you're dealing, let's say, with a database application, or just like a piece of information you want to get, but it's not actually giving you the information that way. Or let's say you have a list and you don't actually have the ability to sort it in a way which would make it much easier for you to use. You would feel as if the applications, it would be making it harder to accomplish your task, even though the information is there, you know it's there, but it's making it really hard for you to get. That's what that's all about. Reduce short-term memory load. This comes into play is that there shouldn't be something that's on one display that disappears that the user should have to remember in order to perform their task. Everything that they need to do what they need to do should be on the screen at the same time. And I've actually dealt with applications where you have to see a file and you won't know. That would have to be closed before you use that file name, which you need to use for the next step. That's not good design. Okay, so this is a wearable design problem. This is one that I came up with for my application. Students on average can stay attentive to a lecture for no more than 20 minutes at a time. And typical college lectures, are 60 to 75 minutes long. A lot of students go in and out, take a nap, show up, things of that nature. According to the encoding specificity principle, which is a psychology thing, human memory recall performs better if the retrieval context is similar to the encoding context. What this means in a nutshell is if you were in a room and you learned something in that room, and under the conditions in which it was you were learning it, you'd be more likely to remember it when those conditions come back. You may have experienced where you've smelled a familiar odor from your childhood and it brought back childhood memories or memories of some event or things of that nature. These are context cues. They can be visual, they can be audio, they can be whatever the correct term is for scent. They could be any one of your senses. Also, it's been found, and I do have a reference for this, that context cues are very helpful for recalling information that's not new. This is particularly good for when you're dealing with a lecture situation where the material most likely is new, that you haven't learned very well, and you only this is the first time you've been exposed to it. Therefore, it could be possible that only a context cue could actually bring that back as it has really something.
We're talking here about the Pavlov ring bell, where you say something for it. And then just ring the bell in the exam room during finals and ring it all the time.
Oh, yeah.
Flash, remember that.
Oh,
Reinforced over. That's not the signal you said.
most likely agitate the students to make them realize that the bells are ringing, so it's time to take the test there or something. So, for my project, designed a wearable context, aware class notebook, which I call Wearables. Conceptual goals of the application are to facilitate the capture of textual information from the classroom, allow easy retrieval of this contextual information to enhance the studying process, link contextual information to textual notes that the student takes, and facilitate sharing the lecture experience. So have a friend in this class. Technical goals of the application: I want it to be small, fast, and efficient. I wanted to have the ability to capture audio streams. I wanted to have digital image capture. Wanted to run on Linux and support multiple platforms. Attempt to use a common graphic system as opposed to dealing with the hardware directly, mostly for portability reasons. Ended up using X, so I also considered using micro Windows. And information should be exportable to a common format. And the application I designed is capable of exporting the notes in an organized fashion, images taken associated with the notes, and audio tracks to HTML web files. To HTML documents, which anything. The HCI goals, where I want to be usable by non-technical people, students who, for instance, are studying biology. Not that students who study biology aren't necessarily technical, but I have a roommate that studies biology, so I want him to be able to use it. That's usable while in motion, while walking, talking, whatever. Interface, I want it to be as intuitive as possible and only present the minimal amount of functionality needed to perform the task at hand, as opposed to information overload and having tons of options. When you're dealing with a wearable system, you really want to have what you need right now, and that's it. Visible challenges: 640 by 480 head-mount display, main input devices, a QWERTY keyboard, and there's limited computing resources, as opposed to having big memory. You have 64 numbers. Of course, you're still that too. Design. What I should probably show the actual application, and then explain. Design. I have some pictures, but I think this will be easier this way. This is the application. This here is the notebook organizer screen. Now, there are a few keys which are used to actually go through this. There's a next and a previous, which basically is tab and shift tab. There's a do action, which is mapped to enter very conveniently. There's escape, which is mapped to escape. And there's the arrow keys, which can be used. They're just two simple key combinations, which can be used for textual navigation, which I'll show in a moment. Also, they can use the arrow keys in lists. For instance, I can go here and go to the notebook browser and choose which notebook I want to go to. Over here, this course information. The reason why there's all this blank space is because I'm intending to put more information there, such as the actual schedule of the lecture and the time. It was my intent, though I haven't had time at this point, to actually having a course location being mapped to a context-aware GPS system, so it would know in the classroom, and it could begin, recording things then, things are, and also knowing the times of your class, so we'll know if you're in the classroom at the correct time. So then I can select a notebook, and I already created this one. And this is the notebook editor screen. The notebooks are divided up into topics, general subjects, and notes. As you can see, go back and describe part of the interface. Use blue, saturated blue, though it doesn't really look desaturated on normal displays. It does on the LCD. Blue with red. Black indicates, well, black text is easy to read. When you actually, select an item, this becomes an active, that right here, and there's blue and then there's white. Blue and white, blue background with white text, I find to mean that the item is selected. As you see, this is consistent, it goes across. And actually, if I was going to be editing a notebook's information, so I would choose update info, choose notebook. You see you have this actual blue streak going across the screen. So you can actually see pretty easily, looking at the screen, what's going on. If you're updating info, you know what notebook it's for, and you know what field is currently being edited. As opposed to using a menu system or one where I switch screens, for instance, if there was a main menu screen and it had all these options. Then I chose one option, then I chose a notebook list, then I changed the screen to just show the information. This way you actually have a view of exactly what's going on. That and the fact that I didn't want to have people to actually remember those things is the reason why I chose to use one screen to do all this task. Also, kind of show notebooks. Again, this is the same. This is just like you've already seen before on previous screens, so it should be pretty intuitive as to what these buttons do. There's a list next to a set of red and blue action buttons. One says open, one says new, and one says delete, just like you did for the notebooks. So the user will already be familiar with this interface. You can open a topic, and to the kinetics. And there's also at the top, you notice where it says editing topic, open topic. If I was going to something else like new topic, it becomes an editable field with white on blue. And same for new topic. This is a set of notes under genetics. And currently you're viewing a live video screen in the viewfinder. That can be changed to showing snapshots by hitting the F1 button to change the mode of that. And this here is a picture of DNA on double helix. That's this camera here. This camera costs $30. It's USB, it's cheap, and it works. It's not optimum by any means, probably not serve the full purpose that I want, which is capturing notes from the board.
I see what John was commenting, that you took a picture of the model of the DNA.
Yes, that is correct. Actually, the diagram in the next one.
That does have a microscope plugged in the USB.
What brand is it?
It's an IBM camera. They don't actually make it though, someone else does. I don't remember, but $30, it works under Linux.
Yeah, that's the important thing is having worked on Linux.
Right, yeah, and it's more, I mean, proof of concept, with the actual Netliner, which is I'm using for my wearable prototype, it has a capture interface, and I have a people camera, which can do more than 640 by 480, and it works pretty well. It's fast for updates.
Speaking of that one, I want to call on the hard drive there. How hard is it to update the hard drive there?
The hard drive is standard, small ID hard drive on a laptop. It's not difficult. I mean, I haven't actually placed it, but I certainly been inside the Netliner. I saw it.
How hard is it to rebuild the system like that?
Oh, how hard is to rebuild the system? I've done that as well, actually. It would be easiest to hook the hard drive up to another machine, and we create a base system on there to start with, to be honest. Unless you have, other systems available, and you can have to try to set up a network boot, boot key or something like that, NFS server like a file system. Actually, yeah, you can do that. As long as, one file is bigger than the flash. So, you can do this, and I have done this. As long as you have this is the infrastructure to support that, networking and another machine, hard drive space. Yeah, it's actually not very extremely difficult.
And if the old Windows drive will work, we're going to get back.
I know. Sure. Okay, so all these notes here are timestamps at the moment of creation, and at the moment of creation, whatever you're looking at will be a snapshot. In addition, it actually, so let's say, I say like joke now. This is working, I should be able to stop the audio. I'm not assuming that you have full duplex audio. Normally you'd be in the classroom, you record the whole thing, then you listen to it later, because instead of listening to it in the classroom. But you actually can select a note. This is not an optimum interface for this part, I see. This part is still in progress. These sections here above the editor and topics and BRADFORD, for the most part, I think are pretty solid. The actual audio playback interface right now, the actual having this thing just play audio thing, I don't think it's enough. It should be more, it should be better than this, but it doesn't work. So, see, it'll actually figure out. It'll calculate where in the audio stream was that you took it, like from the timestamp note, so that you can go to any note when you took it, and it actually goes, well, it doesn't yet, but it's going to, 5 seconds before the point you actually took it, because human response time is approximately 2 seconds, and then just adding 3 seconds to get 5, because 5's half of 10. And that, I think that would work better just for insurance purposes, because insurance, and you actually hear if you actually hear what was said, the audio content that triggered you to take the note.
Is it actually recording the whole time, or is it like a circular buffer?
No, it's recording and filling up your hard drive all the time. It says record on. Like now, see, audio isn't really playing now, but it is. So I could actually right now, create another thing.
It just cannot play video, cannot play back while recording audio.
I'm not assuming that the hardware is capable. A lot of hardware is not actually capable of doing full duplex playback game.
Just out of curiosity, what do you
file format you use?
What I'm using right now is a, what I'm using right now, there's a library, there's an open source library available that I found, so I wanted to put it together, and I have left them 2 days. AFlib, which has capability to interface to 3 different formats, MP3, various types of WAV. What I'm using right now is log encoding, which is it's a logarithmic encoding. It's like G.711, which is commonly used for the telephone, for like voice communications. It's certainly not as good as, say, MP3, but the thing is, I need to have a random access format so that I can take a timestamp, calculate an offset, and go to it and play it back. So that's why I haven't done anything to this higher compression yet, though I certainly will look into that. The current rate, it's approximately, well, I figured it out yet, right? For a minute, there was around a meg. So, for maybe 60 megs for a standard lecture. Yes?
How do you get around recording your audio? If you wanted to record an instructor at the front, how do you block out all the rest of the noise?
How do you prevent?
Or the ambient voice, people coughing. Talking off to the side.
What it actually hears is, like you said, it's extremely dependent on the microphone, where it's pointing and whether it's omnidirectional and its capabilities. That's not, I don't do anything in software to attempt to deal with that. It would require, an AI type system or something with, the correct filtering for the situation in order to actually even determine what would be noise and what isn't something you actually want to hear.
Well, the next question is, why would you try to do that if your instructor, if they're talking to a room and bigger than this, they're probably going to be using some sort of microphone. And to be able to approach that, what they're saying clearly, and then feed it into your system.
Well, actually, to directly feed something into the system would require a wire or a wireless type connection or something, which may not necessarily be available. This is designed to be, used to have a microphone that's on you, or having a conversation with someone. This specifically is for the classroom, but you can see it as generalized to a general media collection type application, which you're using all the time in order to, capture snapshots and, talk to yourself and then, write what you're talking about or talk to someone else and, take notes on that conversation. Actually have the ability to, directly go back to what they were saying and see what, you were looking at. All of this, for a student, can help recreate the contextual experience that they were in the classroom, which will help them, I can prove this, could help them remember the content from the lecture, as well as just the fact that you can play back the entire lecture.
But to that point, they are already, the newer media classroom people here are allowing you to do that even for your small cassette recorders. And there is one of the wearable projects that's incorporating that so that it is.
Oh, they are?
There's also, for like enhanced classrooms, at Georgia Tech, they have they have this program, it's called Classroom 2000, where all the lectures are recorded and things of that nature. It's one of the things like that. My paper's on?
Technically, we're supposed to start by 9, so we're over it.
Yes. Sorry, what was it called? Julian? Classroom 2000? Georgia?
Yes. Yeah, actually, this is where I left off. Navigation keys. Okay. So navigation keys were, I discussed, there's the index in the previous, for changing shift of focus. There's a do action for saying confirmation. There's an escape action saying, no, that isn't what I really wanted, or go back a mode, or let's go back to where I was before. And also there's toggle buttons, which are represented by function buttons, the F1, F2, F3. And the arrows, direction keys, which are used for textual navigation and manipulation of lists. And all of these combinations actually are really simple to do on the screen.
Question.
Yes,
Have you considered using some sort of scanning device to watch the eyes?
that certainly has been, I mean, I personally haven't looked at this, but I have seen research done for, like watching where the eye is used as a fluid, and that certainly has been looked at. Yes.
Yeah, a lot of this type of stuff is actually being done right now by the military. And the military is actually funding a lot of research into wearable computers for a lot of very good reasons. And I think a lot of technology in this area, in this field is going to come in through the military.
There's the current military program, it's called Land Warrior. They have a system now, don't quote me totally, I believe that includes like, it's a ruggedized PC, I think, that runs Windows, but they have others too. Actually, like, went to the Linux Center and saw some of this, but they definitely are doing research in that area for, better equipment, identification of like, enemy or friendly foe, or getting, maps and other, navigational information directly to the soldier, or dispersion of information in general, as well as, ad hoc, networks, wireless networks, sending them up on the fly anywhere.
Where was that?
The Natick Soldier Center in Natick. It's
Yeah, but even
Guaranteed
first
test.
warehouse time.
yeah.
Everything feels ready to eat to latest electronics.
The other good area that you didn't mention that really helpful is the health arena.
Oh, absolutely. There's a lot of use going on the memory glasses, which Yuval, the Media Lab, is one of the projects he has for the Mythrol wearable computing system, which is MIT's latest context-aware development platform. Is a project to help to provide augmented memory agents for the elderly. And what augmented memory is basically, it's using, trying to recognize, like, from context or what the user is typing or doing, things which they have already done or information they already have, which would be which the computer thinks is useful in the current situation. So the computer can remember it when display it. Bradley Rhodes created the augmented memory agent. That could be what it's called. It runs in Emacs. And this was done a while ago. Yeah, remembrance agent, that's the right word. Name. And it actually, the remembrance agent by Bradley Rhodes, or Brad Rhodes, or I don't know what he prefers to be called. But it actually will index files on your machine, and like depending upon what you're typing in an Emacs buffer, if it sees something that's similar or it could be related, it will provide prompts, informing you that these documents may have information that's relevant to what you're doing. It may have more capabilities than that. I haven't used it very much, though. I haven't looked at it.
It kept 3 lines of information. One was to look up relevant sentence. The second one was relevant
Word processing.
paragraph.
I spent a lot of time getting word processing.
Let's see, font size and yield size. Yield size usually is an indication of how much information typically you expect the user to store in a particular field and how much you want them to have viewable. Places where this came into play, for instance, was the notebook browser list. How long do you want a notebook name to be descriptive enough for to easily identify what the notebook is, while at the same time not taking up too much screen size. That I made like 20 characters, which I figure is sufficient. It does scroll if you add more, but that seems to be sufficient for most names. And font size we discussed. User color, I showed off the blue path that I had, that shows what's going on within this application. Here's a screenshot. This is showing, as I already demonstrated the application, I wasn't doing it to the end, but I jumped ahead of myself. Let's continue. This is a screenshot of the notebook organizer. Some things I didn't mention before, things that aren't inactive are grayed out. Like on the right, that's a pretty standard thing that you see, in Windows, when most people are used to that. That way you don't actually think. The actual titles at the top, notebook browser, notebook information are grayed out, as well as all the fields. And then what happens is once this becomes active, these buttons will become grayed out because you no longer select which buttons go up and down, because now the selection things are switching different. So you actually use the arrow keys here. Just select the notebook. And the information thing is, it says it's active, though you can't move focus there yet, but it's active because it's going to be having updated information, so you want the user to be aware of that. Again, every action should have some sort of form of feedback. This is the form of feedback I had. Change the color here for open notebook to the blue on white, so it's active and selected. The background went gray on the other buttons, and things became light from being gray. For update info, it's important. It's the same thing. You have the blue path going across. Also, something else that I did was the cursor position. Whenever you open up a field at a lettable text or a note, the cursor will be positioned at the end of the text as opposed to the beginning, which a lot of things do. The reason why I did this was I figured that most of the time when I'm editing something, I either want to append or I want to delete what's there. And the first thing you usually do before you delete is go to the end so you can hit backspace. So I decided to just put the cursor at the end to begin with, to save time and trouble. That's a picture of a binary tree, a complete binary tree. This is the notebook editor to start the board with the viewfinder. The reason why actually I include the viewfinder because you would say, oh, well, you have the camera strapped to your head and it's going to take a picture of whatever you're looking at. You would think so, but not necessarily. The camera's angle of view is much narrower than human eye. So in order to actually have an idea of what it really is focused at, you need to have a viewfinder.
That picture we're using the fisheye lens?
Oh, the fisheye lens? Well, I mean, you could still then assume, I mean, the fisheye lens is like the bend around like when you're looking through like one of those peepholes in the door, right? Is that what you're referring to?
Yeah.
Yeah.
Elevator
Pictures of
here,
it.
Oh.
corner is the safety.
I remember one time I was using one of those, it's very confined space, I could get a decent image. And that's it. I was standing on one side of the camera holding against the wall, and someone else on the other side, and we were both picking. I was kind of surprised at that one.
Was it actually, I mean, was it distorted or was it?
Oh, yes.
Yeah.
Okay. So, I mean, you certainly
There's
could.
some software that can distort it.
I'm sure there is. So, I mean, there could be a way of getting around that, but I didn't.
Probably more expensive than you see that.
Oh, absolutely. And I'm sure, I mean, there could, again, it's the application is specific for, the situation and, the task you're trying to accomplish.
So 2 points on that, though, because if you're talking about the creation of lectures, 2 things in particular that are not necessarily that obvious, because you're choosing the functionality of the cameras. Okay? One is the zoom. I mean, a lot of times it's too small for the writing on the show. And another is the manual override. A lot of photographers will realize the value of this. You're behind somebody's head, and the automatic focus ones don't allow you.
Right.
You can
Right.
see back to somebody's head for nice, but everything else in front can be totally something. So the manual override with both focus and exposure.
Absolutely having to the correct camera for the task and distance and the situation which you are in isn't. Another thing is, I figured instead of capturing video and taking up space, was I just stick with snapshots for simplicity. And in a classroom situation, we typically are very interested in what the professor is doing motion-wise. We're more interested in the content on the board. In a dancing class, this would be a different story. But for the typical lectures that this would be for, that's the reason why it's having video would be.
How
capture, and then have the camera take the pictures, like 1, 2, 3, 4.
The way this particular system works is you see something in the viewfinder, you take a note, whatever was in the viewfinder gets captured. You could definitely go about having to do things like that. I think there's actually a camera that does pseudo vision that comes with it's a Lego Mindstorms robot extension. It actually has software for using the camera to designate like different areas of what is being seen, to say like if something is in this area, perform an action. I mean that's the type of software it definitely does. If it does exist, it could be used. Yeah.
Yeah, just a quick question. I know there's also been work done on like face recognition, that kind of stuff. You're walking up, you recognize the secrets in the hallway.
Absolutely.
What about the, like, I don't know, maybe some kind of infrared action to figure out if people are lying to you or you're talking to them? Yeah, part of you or something?
As far as lying, I did hear about a piece of software that I never tested, and I assumed it was a piece of junk, but supposedly that was a software that you could run on Windows that if you filtered, I believe, someone's voice through it, it was supposedly to try to tell you if they were lying or not. I think it was just, well, I don't think it was a joke. I think they were really trying to sell it, but...
The Israeli police or somebody has...
No. I don't remember the company, and I haven't heard about it again, so I assume that it disappeared. But it was, I did hear about it from a few different sources at the time.
I have,
So that's kind of interesting. But like, you were saying infrared, right?
Well, it's something.
I mean, infrared is commonly used for location identification through having tags in a room for communicating, like storing very small amounts of information. That Starner has something that was called swarm of locusts. The crystal tags that they have now, that's newer than the swarm of locusts. And they have those too, which a person can have on the wall, or they can have in the actual room. Though the crystals actually have four LEDs on them that make an angle mount to cover a wider area, so that what the Mithril system has, Mithril is the new MIT wearable prototype after the Lizzie. It has on the glasses on display, it has an IR detector, which is used for receiving stuff from the crystal things. But IR is useful for location identification, mostly within buildings, because GPS doesn't really work throughout most buildings. I have also read about barcodes being used for location identification. There was a wearable, I don't think it was not totally like a real wearable, it was more like an advanced PDA system for Carnegie Mellon had called Metronome, and it was like a guided tour, I think, for people that were visiting. And you would have location barcodes across the campus, and they could go and scan it and pull up information.
We do for wine. You have a wine that you wave over something, or it's like shooting lasers all the time?
No, you have like, I think you actually get them free at Radio Shack. That probably, I don't know if probably someone has made that work.
There was an article in 2600 about it a while back.
Yeah, I read that one. That's why I don't use it.
Right.
I just wanted to ask.
Yes.
Can you go back one? Those little entry areas where you, when and how is the user expected to put that text in?
Okay. What happens is, I didn't explain this very well. Once you select a topic, it becomes so that you're editing that topic entry. Whenever the user enters any text, it will automatically. The reason for this is I considered that taking the notes was the most important task that they had for using this application. So the most common thing they're going to do is hit a button, so they should be able to just hit any button and start recording the note. As opposed to having go through, select a button that says, I want to have a note, and go through a bunch of interface junk. You just start typing in, create a new note, timestamp it. This way it's instant, and it'll be more closely correlated with the actual time the note has created with the event that's taking place that you want it to be correlated with potentially, such as the audio stream or the snapshot. One thing that isn't obvious is that you can select well, there's two levels of selection within a node. This first is there's just this blue highlight that you see. And before, when I was showing the application, which I'll do again at the end if we have time, you would have just the blue, but the text would be black and the background would still be gray. That means that that node is selected, and that if you do an action such as choosing play audio, it would be associated with that node. If you're showing a snapshot, the snapshot is associated with that node. But if you try to edit that node, you can't, because if you hit text, it'll start to make a new node. So if you hit the use button, it turns white, the white background and the white timestamp, which correlates with the this path of blue going across. So that tells you that you're in something that you can edit. And then you can actually perform the editing, and then you can enter again. Confirms it, saves it. If you hit escape, it'll delete whatever you typed there and go back to what it had before. So there's several levels of with that. The one thing that isn't obvious is that if you select a node and you backspace it, delete it. That was so you have to have a delete button or additional level of choosing an actual visual, visual button or something like that. Because I wanted this to respond quickly and be it's easy enough to interact with without thinking, because you want to be focused on the lecture. And I don't have to look at that. I know that if I'm typing something, it's going to make a new node. I know that if I hit enter, then I can type another node. I don't have to really be looking at the screen. Or if I need to point out something.
Have you done anything in this regard with speech recognition?
I myself haven't. Certainly, lots of research has been done with use of speech recognition as a for wearable computing systems. Of course, there's always good and a bad side. The typical issues you run into with speech recognition are: am I talking to someone or am I talking to the computer? Filtering out background noise, and also having the computing capability of actually being able to process it in real time. That's another for I'm sure many of these issues will be addressed in this technology. The rest is maybe already have them, I just don't know about it.
Well, the short answer is obviously because of the small screen of cellular phone and that kind of technology has been pushing through some of this good mix. Just like there's a good number of design criteria, just like we had before, where you can, it's just like if you want to take a phone and call up and make a ticket charge, they're going to give you they're going to figure out if you're home, press 1 if you want to leave from Boston, and you're calling from Boston, they're going to give you betting on limited, like you're saying, the most pertinent information.
Right.
In some context that they get required and immediately then in your databases. But the mix of both, press 1 and or say, so that mix, as opposed to voice XML, which just came out a few months ago, and different sort of thing, is not allowing you to vote.
Well, I know, they have voicemail systems that allow you to say a number.
Right.
But those are specific, words, and it's not felt to handle with natural language. It's more just having specific things.
So it wasn't too difficult for you to get fairly dexterous at typing in with that?
Well, I wouldn't say that I'm perfect at it yet. I'm getting better. I can type pretty easily with OS. And I haven't really had any difficulty with it, but I also play guitar, and this is very similar to fretting on a guitar or a bass. So it probably may take someone else a little bit longer, but it really isn't that hard. I also I added a piece of foam here in order to move my fingers fit further apart to make it easier to touch the end buttons. Yes.
Yeah, Pat Starner was spoken to us a couple times before, Brad mentioned. He used to use that as his primary system. And essentially, he could essentially operate that whether you couldn't even tell. You would be talking to him and you would be typing into his wearable computer all at the same time, and you wouldn't even see him do it. Because
you can't get very used to it, and usually that's comfortable with it as you would a keyboard. I do think that our I'm on my way.
Is there a wireless version?
I don't believe commercially there is, but I read about something on one of the handhelds on PS2 serial numbers and stuff. I was working on a radio version, packed version of the tape. So commercially, no, but you can certainly make your own modify it. It's not intended. This comes off, this strap goes off. I added this myself. This is not part of it, it's symmetrical. And you can put it here. And the keys you can map however you want. It's totally programmable. And play it.
I know you don't want to like go back into your application and do stuff right now.
Oh,
Could you do? Okay.
I would certainly like to show off my application. I spent a lot of time developing it. Actually, I was just getting at this is getting close to the end of the actual slides. So let's talk a bit about the actual implementation, what I used. So in C++, I used the FLTK toolkit, though. I mean, most of the widgets I made myself by deriving new widgets with C++. You derive classes and things of that nature. Though when there were some things that I actually had to go in and just change the library to do. For instance, whenever you make something inactive, it would change the highlight color in the top of this to pink, and I wanted it to be the same blue. Because what it's doing, it was just doing a standard, what's the correct word for this? An adjustment of the color based upon, like in testing, what the color is, just wanted to make all the same colors lighter. So it was just doing that for everything that was inactive, but for this case, I didn't want it anymore, so I just changed it. I use pthreads, which is not the easiest thing to use with C++. You have to use some workarounds to get it to work, and the reason for that is that the pthread create function requires that you pass in void data, void pointer, and you get the problem. C++ does not allow casting to void initialization, parameter passing, things of that nature, and it gets very annoying. What I actually did to do that is I put the actual pthread create function in a C wrapper, and I passed something in. I created a char star that I passed in, and I cast everything in C++ to char star, and then I converted that to whatever to void in C.
Aren't there classes that are layered on pthread?
There certainly are a few that I came across, but I wanted to use the library directly. I was trying to keep minimum weight possible. The only reason why I actually used the AF nib was because I wanted to have some working really quickly, and I've been working on a bunch of other stuff. And it would handle a lot of like the buffer and other stuff. So that's why I used the AF, which is actually it's really cool. It's a free open source audio library. So the graphics, I looked into using a few different things. There's a MetaQT, there was micro windows, and there was X. Lightweight versions of X are available, for instance, in the iPad handheld or CRM. Very cool. Micro windows is also available on the iPad handheld and some other things. I chose FLTK because there's support of that to micro windows as well as on X. So AF can do my development on standard X desktop, and I haven't actually ported this to micro windows. I know that an FLTK version exists for that. I know that the popular web browser UML, which is from I believe months at least, it uses a combination of FLTK with an HTML widget from ET, and that runs on micro windows. So I figured that it wouldn't be too difficult to get this to work on micro windows if I wanted to have that.
Question on the audio, because again, with your application, later you want to, the words of the lesson are still so important, and so, like, in terms of the audio playback,
Right.
with this set of implementations, would it be easier or not with this one, or would you choose, what would make it easier to include this functionality of a on-the-fly speed control during audio playback?
Speed control for
When you are
for how quickly it plays back the speech,
faster than normal and slower than
with or
normal
without
when you are-
pitch distortion of the voice.
Well, that's what the two, yeah, obviously, yeah, the two.
I mean, for actual implementation of that, you would either, first you use whether or not you're using hardware filter or software. I know the soundbox for live cards capable of doing this, because I've done it. You can play that change the rate, but not sound like chipmunks. That's certainly what it does. So, I mean, that technology definitely exists. It would simply be a process of then mapping the control to, you know, the rate, which I'm sure would be difficult.
With your given
So, I mean, with what I have, I first of all have to figure out how to implement those algorithms, and it's already been done in other software, but then I want to integrate that in on and write my own, when I have the additional hardware. I mean, it certainly could be done, but, I mean, for actual playback, the playback interface is not yet complete. Currently, you can only choose a note and have to play that. I am going to have, like, a bar, and also that will show where in the file it is that can be moved. I intend to have, you know, another mode. One of the buttons that says watch videos. That's actually going to be a mode where you can go and look at your entire media catalog, because there's a catalog system I created. All the media across all the notebooks is cataloged in this, and basically you can send it a timestamp, but it will tell you all the valid media that's available in that time. And also, I tend to modify that to include location and other types of context cues as I expand on this. So you can.
I want to mention this, and the point is, when you're going through a review, you really, for a 40-minute or 60, even 20 minutes, especially review, you don't want to go through the whole thing usually. You understand most of it. So, and skipping ahead, so Apple and Stanford did a lot of work on this ways back, and there's a hot paper on it. And they were doing a news scheme where it wasn't even a review, but it was just the value of your time, because it was what?
What you're saying is basically fast forwarding through it to get to the point where you want to get to. Is that what you're saying? Or to actually retrieve the information by hearing it more quickly or more slowly?
Both, actually. There's also an intention of keeping quality of your changes to be a little bit, but mostly it's for saving your time so that when you're hearing it, like you did in your newsfeed, and you're going faster because that part you understand it's and then you're going slower and even slower than it was before the pertinent jargon or whatever it was. And they were going, 10 years ago, it was in most answering machines, 2 times faster or half times slower. And so that functionality of saving of time is critical to
well, sure, that is like on my group second quarters, we have like half speed.
Right, and the Apple Stanford thing was up to 3 times for most, but the critical point was, unlike the Braille screen readers where you have to stop everything, go up, change, you make some control changes. This is something that is essentially a slider or knob control on the fly is critical, because it's like a split second of keeping it at your pace and valuable.
Right, well, I see what you're saying, and that certainly could be something that was interesting to integrate into everything. You have a large amount of audio that you're trying to play back, and if you want to go sorting through it or trying to find particular things. What I've been doing, right now, what the Wearbook application will do is, if there's something that you know that you're not going to know during the class, you just make a note, and you can go right to that position just by selecting the note and telling it to play it back in that area. And when the implementation is finished, they'll actually be a bar. Some other information telling you which file you're in, because every time you start and stop the recording, it does actually create a new file. So the media catalog figures out which files are valid, and then figures out where in the file to go, so they're not selected.
When you say media catalog, are you using some sort of database program, something you created?
No, I'm using a linked list, and that's basically it. It's a linked list of classes. It's just something I created. And basically there's a base class called media, which I derived from media type software, media JPEG, or media wave file. And basically it has an ID, and it has the base functionality of understanding the time stamp system, which is just a wrapper class around standard time standard C functions. And basically it says, this is something valid for this period of time, there's a start and an end. If it's valid within there, then it will calculate a second offset. We use the sample array, the wave file, multiply that, how many samples per second by the number of seconds to get the offset, and adjust it wherever you want. That's how it works. Video for Linux for video capture. I've actually done a few different things with that. Kind of dealt with creating classes to Video for Linux 2, because first of all, when I was first doing the video stuff, initially it was with the Netwinder. The Netwinder video capture implementation currently is like hacked almost sort of for L2 driver, but it's not in the kernel really. It's basically you download it off the website and you try to make it work. It didn't normally work for me. I had to actually go and adjust certain things. actually, you can get it to, just to acknowledge capture. And it also doesn't support M mapping. I have seen some stuff in later versions of the kernel, though the last time I tried it, it still wasn't working. Though maybe at some point that will. So this is sort of an implementation that work with 2.2 kernels. So I did some stuff there. Plus, I have two different classes. We're going to be for all 1 devices and be for all 2 devices. And also, there's 2 different ways of reading information off a video device, video for Linux. You can read using the read syscall, or you can mmap, which create a memory map and just give you a pointer and go. And the driver for this camera supports m-mapping. Lots of fun. No, like that. Say thanks for listening to me. So the driver for this does support m-mapping, which is convenient, and the one for WPI for Linux on the networker doesn't currently. So earlier in the year, I was going to have less than that, but I don't do cover. So basically, all this stuff gets in within classes, and class all we do, and one or the other just magically work. That's what we made sure that it would magically work. So this magic is really not. Yes.
You mentioned the networker, so when we had Pat Bernie and guys who developed a couple of years ago talk about it. Has it advanced any since then, or is it pretty much a dead product?
I believe it's a dead product as far as like commercial, as far as all that. I mean, initially what happened, we had Pat Bernie, who was a really, really cool speaker, came and talked at the Linux users group. This is actually how I ended up coming across this people in that one, because one of the guys there was a sales guy. I was like, well, can you get these in the ACM lab? Because at the time I was the WPI's in chapter's ACM vice president at the time. And so I was trying to get new stuff for our lab. And I was like, oh, well, I can borrow this one. And then he like disappeared and never wanted me back. So.
You can still buy them at Wearbook.com.
Yes, that's right. The history goes, Corel sold it to a company, I believe it was called HC something or other, it was in Canada. And I believe they sold it to Rebel, and I believe Rebel was trying to clear them out for something different that's not StrongARM based.
Oh yeah, they have another version that basically has the same enclosure that you use for searching, still StrongARM.
But basically, for anyone who's not familiar with what the Netwinder is, I mean, pretty much what it is, it's a platform designed for running Linux. It uses the StrongARM SA110 processor, which is, basically it's a low power processor that runs at 200 megahertz, has integer performance of around maybe a penny 200, has no floating point unit, very low power. The actual newer StrongARMs, the SA1110, that uses less than 400 milliwatts of power capacity.
I think the first one that you mentioned, I forgot the number, but I think some of the Windows CE units are built on that.
That's very possible.
Okay,
I think that's not a 680 unit.
ARM in general has been used for a lot of Windows CE units. Usually Cardano uses an ARM chip. The iPad uses the StrongARM SA1110. Yeah, so StrongARM is very, has a good role, say, in the embedded small portable computing market because of its low power, high performance. Yes.
So where can we download this note-taking application?
Okay, currently the source isn't available right now because I don't think it's presentable enough. I want to take out warnings and stuff. I also not finished with it yet. I do plan on making it available on my webpage, which currently is tilted Bradford off WPI's, www.wpi.edu. Though when I graduate, I'll be there forever. No, I won't. I just need to finish 2 reports and my 2 degrees, and I'm done. But I do plan on making it available because I definitely want to get people using it. There's some really cool stuff I didn't even show. I have some of the files. This used to show a lot of the bugging output that I took out long-term tests.
How much space does this take up?
Um,
I mean, for the FTP sake.
well, as far as, I mean,
We probably
text-
got space on our server, it's not like 8 gigabytes.
oh, well, it's not, large. The actual code itself, the code base, just code is like 300 something K. And that's uncompressed. I'll make sure that when I decide to release it, that the BLU is important, so if anyone's interested. Depends on the platform, of course. This is with debugging information and unstripped, and it is
How difficult was it to?
it's 1.1 megs. How difficult?
How difficult was it to get the live video piece embedded in your application?
Well, I mean, it wasn't extremely difficult. I mean, I did it all myself. What it is basically is I have a thread which I create, which I mean, what it does is it reads off the video device we're using in class that I created to open up Wearable Linux Capture, and it uses the MIT shared memory facility to display it to the screen. The Netwinder actually just used, it has a hardware preview capability, so I just programmed that to do it right through hardware automatically, so it's a much faster uptake. Plus it's much faster interface since it's a video capture thing. But I mean, it certainly took a while to figure out exactly how to do it. But I didn't find it extremely difficult.
You think the frame rate that you get over the USB bus is sufficient?
I think it's more of a function of the camera's ability to capture the frame than the limitation of the USB. The current frame rate, I think, for this particular application is fine, even if I was doing video capture, because, again, like I was saying, when you're in a lecture situation, the emotion of the professor most likely is not extremely important. Also, for the long duration, which you can be recording, like, 5 lectures a week, 70 minutes long, you don't really need every single frame of that anyways, and it can be a waste of space. So this particular application, this camera really needs just to be the next version up that's higher resolution, maybe with a better lens. But I don't know, I got this for just making sure I get things to work.
How big was the hard drive?
Hard drive depends on the Netwinder that I use as my Wearable prototype. The hard drive is 4 gigs. On a handheld that you're using, if you're using like a modified iPad, you can get a 1 gig micro drive. This particular laptop, I believe, is a 4 gig hard drive. I haven't recorded full lectures yet. The implementation is going to have all the way there. I was in classes and all last term, I didn't even have any classes. Because I wanted to finish up the classes. I just brought it up.
I checked a couple days ago, I think a 20 gig graphics driver, this group,
See, the thing that you need, when you get the wearable application is, you're either going to want to go with a micro drive or a laptop drive, which is probably because those have, they have lower power requirements, they're physically smaller, and they're more resistant to shock, which is important. So what I
I just want to mention, in case anybody, there's going to be, optical people are going to give a talk here, and probably going to be next month, so if you want me to send you an email, it's just Nikon like a camera, and IKON@world.st.com, my name's Mary. So I'll tell you the details.
Could you send something to discuss BLU.org? Well, then, yeah, I mean,
BLU.org.
yeah, discuss it, BLU.
Well, if you're actually on the discussion list, you can post it, but if you're not on the list, you know.
Well, but then one of us will get it and go around, yeah.
Who goes to the balances?
I do. This is, I took one note and a new notebook I made for the BLU meeting. And it shows, just showing up the automatic
Balance goes to corporate.
export to HTML. Also, there was something else I didn't mention. You don't need to save. It saves automatically whenever you create something new, or whenever there's a change. There's no worry about data loss. There's no having to say, I need to save this. All that stuff, again, it's taken care of for you because you shouldn't have to worry about that when you're in the classroom. You should focus on the task. So, all of the remedial little things that normally go along with computing applications should be hidden from the user as much as possible. So, if you don't save, it automatically saves whenever anything changes. And at the same time, it automatically generates a web page so that you can share the information with anyone. This one's really small, so we're showing this stuff in larger. It's going to be more hard. That old one is really big. This is the new one. This was kind of small. I'm still working on figuring out exactly how I want to organize it, making the links and stuff, but I think it shows what it can do. You basically instantly you go to your lecture, you take your notes and everything. You have things stored in the notebook. You can use the notebook to retrieve it, or you can also just use a web browser and have snapshots and audio. It's actually embedded audio wave, but it doesn't actually show in Netscape or Linux. And on Windows can't understand ULOG encoded waves, which I found out yesterday. So.
Are the notes, you guys believe that's right?
Not necessarily. What I did was I said that the screens, that those windows can hold approximately 1,000 characters. Actually, that's what it used to be, right? Here's the font size, probably a bit less now, maybe 500. The whole idea is that it's able to hold a single thought, because you want to have the timestamps still have the association of the content. And also, like for instance, another thing I had to deal with was, well, in a real notebook system, you have a pencil, you can draw pictures, you can do equations. So how do you deal with this in the system? You could have, some sort of pad thing you can write with. You could have, they have a thing that you put underneath paper for like the palm that you can write with. I said, draw it and take a picture of it. Well, as a compromise, I figured that with a high enough resolution camera, that would work.
And you can still scribble on your paper, and it's still done.
Right.
Take a picture of the person next to you.
That's right. Saving effort.
I hope he's a good artist.
So, are there any other questions, things? Yes.
Even if you just did it in some text window on your computer, look to see just how fast it is to type on the trigger,
Oh, okay.
even if it's not in your
Do I have to
application.
type something real or can I just type garbage?
Well, any kind of words, typically, not a realistic test, but just type it.
I am not the fastest typer.
Well, but you know where it is.
Oh. Then never mind.
There it is.
I'll just use this and that. That's what I use over, I use.
That way you can hit any characters you want, nobody can read it.
So, I mean, you can't actually type fast. When I'm typing versions, I don't really know all in my head, but I have up and down, but those are easy.
So there is a learning curve.
Oh, yeah, there definitely is. Getting used to hitting buttons and then, getting the mapping you have, automatically just know where to go and how to look. Also, keep in mind, the default mapping on the toilet is alphabetical. It's not optimized for like a keyboard would be or something for frequency. It's just supposed to be simple that way. So there are people that have released their own it's totally configurable too. So you can do this. Exactly. Of course, there aren't necessarily many other people who would be using it.
Oh, so if you learn the alphabetically initially, you might have trouble relearning it.
Yeah.
Oh, well, right.
What's the minimum number of fingers you need to operate with it?
It depends upon how
Somebody
much
who's
function.
handicapped.
It depends, it will depend upon how much functionality you want to have. You could I mean, you could probably need 3 at least, and it would be difficult. I'd say 4 would be best. You could also create macros and stuff too, so you do one key combination, like, puts out a specific whole word, or, big things of that nature. So it doesn't have to necessarily map to a single letter, but map to a whole sequence of commands that you can do.
Does the thumb do anything?
Does what?
Does the thumb
Yes,
do
there's
anything?
thumb buttons up here for number, alt, put them together, you get function, control, shift, and there's an IBM track point thing for cursor or mouse pointer control. Yes.
You said that these notes you take have a maximum amount of characters. What happens when you come to the end of it? Will it just immediately start on a note?
That's a good question. Currently, what happens is it just keeps going on in the buffer. I mean, it's just more or less a virtual limitation. It should be there. It's not like physical crash or anything. In theory, what you do is once you start typing and it gets beyond the place where you can display. And currently, it'll keep scrolling because I haven't modified the widgets yet because I haven't had time. But it should, once you can't say all of that note, it should go on with a new note. Because that way when you're scrolling up and down between all the notes, you can see all the content of that note without having to go into it and move that note around. And also, again, that keeps with the whole idea of what you're typing having something to do with the timestamp of which was created. Any other questions? If you have anything after you want to ask, feel free to ask me. If you want to see these devices, feel free to come up and look at them. Thank you.
No, I'm not just gonna look back.
Although when we had a home here, a year and a half ago, they were just like,
Been speaking to me. Yeah, those being memory aid. Yeah, we just support the SLK partner and ISDN. Oh, that's right, you did ISDN.
you didn't have a hookup.